Hello, everyone, again. Thank you for joining today's Winter Weather Outlook webinar. I'm your host, Stephen Strum, and with me today are a host of meteorologists and other people from DTN who are going to go through the winter weather outlook, as well as some of the potential impacts this winter weather may hold on various industries. I'll go ahead and pass things along here to, if I can, to Jeff. There we go.
Great. Great. Well, thank you, Steve, and welcome everyone. It's time for our annual winter outlook, giving you a preview of what we expect over the next few months. Before starting out on that, just a few housekeeping notes. We are going to be recording this webinar, and we'll send out a link to all attendees when it does become available within the next couple of days or so. If you are experiencing any technical difficulties through the chat feature, please let the host know about that, and we'll try to take care of that as best as we can. And then we have some reserved time at the end of the presentation for questions. We have a lot of material to go through today, but we hope to be able to have some time at the end to take care of those questions. As far as the weather portion of our presentation, we will have our usual three presenters. Myself, Jeff Johnson, been around the DTN for the last 40 years, specializing in long range and seasonal forecasting. The actual forecast part of our presentation will be handled by Nate Hamlin. Been with the company over 18 years, also a specialist in long range and seasonal forecasting. And then the actual numbers that we'll have in our forecast will be presented by Steve Strum, who's the Vice President of our Extended Forecast Services here at DTN, and he's been in the business for over 20 years. So without further delay here, I'd like to just let you know what we're going to be trying to cover in this presentation. I'm going to start out with a review of last winter, and then look at some of the more recent trends, and then highlight some of the more costly winter impact hazards that occur. And then Nate will go into the forecast process, looking at our statistical method, looking at past analog years, touch on the polar vortex. That has a very big impact on the winter weather. And then also look at what the computer models are showing. And then Steve will come up with our seasonal outlook, a lot more detailed graphics and numbers, as well as a heating degree day forecast. And then we'll turn it over to some of our industry experts who talk about aviation, transportation, utility, and energy impacts based upon our expectations for the upcoming winter and how we might be able to best help you out. So starting out, first of all, with a quick review of last winter. We did have a weak La Nina, and just as a quick preview, we are expecting a La Nina again this year, but we're not going to be able to just cut and paste from last winter and say we're going to have the same kind of weather as we did last year. So very interesting differences are expected. But generally, we had a near average jet stream across the country, and that really didn't cause the weather to be in any one particular fashion. But we did have some unusual things happen. The winter started early in October, and then in November, December, and January, the weather became quite mild across the country. But then things changed in February and then flipped back in March. And generally, we had wetter conditions in the Central Plains and across the Mid-Atlantic region with drier conditions in most other areas. But just a big picture overview of the temperature conditions last November to March. The reddish and yellow colors represent above normal temperatures, so basically the northeast half of the country was milder than average, and near to slightly below normal in the southwest half. In terms of the winter precipitation, as I mentioned, the central part of the country was wetter than average, as well as the east central coastal areas, but a lot of drier than normal conditions prevailed elsewhere. Looking Quickly at a month-to-month breakdown starting in November, lots of red on the screen there with above normal temperatures just about everywhere. And then in December, continued warm most areas except down along the Gulf Coast region and Mexican coast. And then January, continuation of the very mild readings, and a lot of people were thinking we were going to get away with an easy winter. And then boom, in February, cold erupted, and we had some extreme conditions for about a 10-day period in the middle part of February. And then that pattern reversed, and we went to generally mild conditions again then during the month of March. Heating degree conditions last year, as you'd expect, less than average in the yellow and orange shades there in the northeast half of the country. And in terms of historical performance of those heating degree days on the far right-hand side, you can see how 2020 stacked up. It was lower than average heating demand across the country. And then in terms of the polar vortex, Nate's going to be talking a lot about that in his forecast presentation. We generally view the polar vortex up in the middle part of the atmosphere, up around 18,000 feet. And in November, you can see that the polar vortex in the blue and purple colors there was located mainly across northern Canada, and that's where we see the cold air bottled up. So that's why November was mild. December, the polar vortex was really shifted more toward Alaska and Siberia with the mild conditions over the U.S. And in January, generally polar vortex well away from the U.S. But then for the month of February, you can see how we saw a portion of that polar vortex break out and dive down into southern Canada and the northern U.S. And then it was ejected in March, and we returned back to milder conditions. So very important how that polar vortex behaves and where it's located. Now shifting more toward the precipitation side of last winter, lots of orange colors on there, meaning below average precipitation. The green would be above. And again, most of that above normal throughout the whole winter was focused more along the East Coast. And then later in the winter, tended to move more toward the central plains. Snowfall on the left would be the inches of snow that fell across the country. The map on the right shows the departure from average with the green meaning above average snow. Where you'd expect there to be more snow, especially with a La Nina pattern in the far northern part of the country. It actually was lighter than average from the northern plains through the Great Lakes and the Northeast. And then down in Texas and Oklahoma, as well as the lower Mississippi Valley, above average snowfall last winter. So kind of a topsy-turvy pattern. And then breaking things down with a little more detail on last winter because it was so unusual. In October, we had that early start. We had record cold and snow that occurred in the Rockies and Plains, and many locations set records for snow so early in the season, as well as record cold temperatures with that snow. Then a major ice storm occurred in Oklahoma in late October that knocked out quite a bit of power to a lot of residents due to that ice falling on trees which still had the leaves on them. So very unusual pattern that developed with that early cold. But then the pattern reversed, as I mentioned earlier, in November, where we had warmer weather take hold. But we still, as we shifted more into the winter season, did get some snow to fall across the country. And the map on the right shows areas that experienced snowfall. Heaviest was in the Pacific Northwest and Cascades early in the month, and then some around the Great Lakes. And then as that storm moved into the central U.S., we saw up to 6 to 12 inches of snow in parts of Nebraska, South Dakota, Iowa, and Minnesota. So it looked like maybe winter might get its act going here. But then in December, again, generally mild temperatures across most of the country. We were able to experience a few good storms, though, during the month. In the middle of the month, a powerful nor'easter brought a foot or two of snow from Pennsylvania up into New Hampshire. And then on Christmas Eve, a storm in the southeast drew some cold air down and brought a white Christmas to the southern Appalachians. And then late in the month, very strong storm hit the Pacific uh, coastal area and then brought some rain and snow to the southwest. And then some good snows also in the central U.S. Into the Great Lakes region. And then January, again, a milder than average temperature month, but we did still experience a few good storms during the month. One in the Pacific Northwest with blizzard conditions. And as I mentioned, with that warmer weather, we saw a lot of the snow melt in the interior part of the country. But then late in the month, we did see another storm in the central U.S. And that did bring snow down into the Tennessee Valley and Appalachians region. And then another good event in the Sierra Nevada region brought some heavy snowfall. And then the Northeast got another good event with 1 to 3 feet of snow. And then we shift attention to February, where we had the major cold outbreak occur, and it's brought the coldest temperatures in more than 30 years to some areas, with temperatures more than 40 degrees below normal during the middle of the month. And then that was followed by some snow events from the central Rockies and Plains, as well as all the way down into Texas and up into the Ohio Valley. And 6 to 12 inches of snow actually fell in the area from northeast Texas up toward the Ohio Valley and to the northeast. Focusing a little more on that historic cold snap in February, you can see on the left how that 10-day period from the 10th to the 20th, how the polar vortex was pretty far to the south, extending from southern Canada down through the central U.S. So that brought all of the cold Arctic air down with it. And those temperature anomalies for that 10-day period were a good 30 degrees below normal for that 10-day period. And then on the right, a sampling of some of the coldest temperatures that occurred with that outbreak. New Orleans all the way down to 25, Dallas -2, Oklahoma City 14 below, and temperatures in Omaha down to 23 degrees below average. So leading up to that, we had very warm temperatures, and then once that cold departed, we started to see temperatures moderate once again. And then rounding out the winter in March, we did have one good event that occurred in the middle part of the month, mainly in the central Rockies and up into the High Plains region, with Denver having a remarkable snowstorm, as well as Cheyenne with some very heavy snowfall. But then we had the milder temperatures take hold and snow rapidly melted across most of the country. Now looking back just on the last few months, just setting the stage leading into the winter season. In July, we had some very warm temperatures across the northwest half of the country and more moderate conditions in the southeast half, and pretty wet from the southern Rockies as well as the eastern part of the country, and a lot of that was tropical related rainfall. During August, very warm temperatures, this time focused more in the northeast quarter of the nation, still wet out in the eastern areas. And then during September, very warm conditions prevailed once again, with the focus of that maximum warmth more in the northern and central plains region. And then most areas drier than normal during the month of September. Just a quick rundown of some of the big events for last year. These are billion-dollar weather and climate disasters reported so far this year. And you can see that the cold outbreak from February shows up there plotted in Texas, but that really affected a lot more of the country. Otherwise, more of the significant weather events this year were severe storms in the Mississippi Valley area and some tornadoes in the southeast. But the big event this year was Hurricane Ida, which came into Louisiana this summer. Category 4 storm with 150-mile-an-hour winds caused $65 billion in damage. So a pretty costly year so far in 2021. Now, as we turn more toward the winter season, what are some of the more costly winter hazards that tend to occur, and just how frequent are they and where do they occur? Well, on the graph on the left, this is a plot of the number of billion-dollar winter weather events that occur. And as you can see by these plots, it's generally one or two of them occur every year or two on the average, although in the 2000 to 2010 period it was much warmer, so we didn't have as many. And the map on the right shows where these events are most frequent. So most of them do tend to occur in the eastern half of the country due to more population, excuse me, and infrastructure in those areas. Now, in terms of all federal disasters, the map on the left shows where they have been reported from 1964 to 2014. But if we focus on the snow and ice federal disaster declarations, the snow events are most common in the northeast part of the country, and the ice storms focused mostly in Oklahoma, Missouri, and Arkansas in terms of the ones that cause federal disaster declarations, so the real big type events. And then in terms of the blizzards, where are they most frequent? Probably where you'd expect in the northern and central plains, where snow is more frequent, but also stronger winds are more apt to develop. Little secondary max there in Maine and coastal New England as we get nor'easter events affecting especially the coastal areas. And then just another little shot here of the freezing rain hazard. These four plots from a research study show in the upper left the average number of freezing rain hours, and I don't really want to focus too much on the specific dots other than the yellow and orange and red ones indicate more hours. So it looks like the northeast part of the country has a greater frequency of seeing more hours of freezing rain. And then we focus more on the long duration freezing rain events. So in the upper right, you can see the events that last long duration, which would be more than 6 hours. Those are more frequent in the New England area as well as upstate New York, and lesser as you move further to the west. But the percentage of events that are long duration events are actually higher down in the southeast. So meaning that those southern Appalachian regions, the Carolinas into Georgia, they don't get freezing rain events too often, but when they do occur, they tend to be longer and more problematic. And then the last one shows a number of events that are more than 18 hours in length, and a little bit more focus there toward the Oklahoma region. So a little bit of a disparity in terms of freezing rain frequency and its impact, but relating back to that federal disasters map, we can see why some of those events in Oklahoma and that area tend to be more hazardous because they tend to be more of the longer duration events. So that's a little bit of a review of last winter season and a kind of a rundown on what is impactful in terms of weather hazards during the winter. Now, Nate is going to let us all know what we can expect here over the next winter season. So, Nate, I will let you take control here.
Very much, Jeff, for that very informative rundown of some of the trends and what happened recently. I will go into the seasonal forecast part of our presentation. Let's start with what goes into a seasonal forecast, and here's some winter season influencers. So ENSO is about 40% of the influence, give or take, depends on the year. And predictability, we're pretty good at forecasting the ENSO phase, figuring out if it's going to be a La Nina or an El Nino, things of that nature. Then a polar vortex, this keeps creeping up in recent years, and that can, especially if you take a look at what happened in February, you can see it has a very strong impact on the winter weather, and we have kind of fair skill in assessing that. We're good at figuring out if it's going to be a problem. It's determining when it's a little bit more difficult. Other subseasonal impacts like the Madden-Julian oscillation or the MJO and snow cover and things like that that can influence the season. Those are shorter duration events that have a little bit lower scale from a seasonal standpoint. And then we're pretty good at determining what happened in recent trends. So we wrap all that together to create our seasonal outlook. So let's take a look at the main seasonal drivers, and a lot of variability during the winter season and any time of year really can be determined by looking at sea surface temperature anomalies. And the map on the right is exactly that. Sea surface temperature anomalies from December through February, the 90-day average, where you see the oranges, that's above normal sea surface temperatures, where you see the blues, that's below normal. And we've focused on a few areas that we like to look at. And west of South America along the equator, we see all those blue colors, that is La Nina, below normal sea surface temperatures. And looking at the Pacific there, look at all that warm water south of the Gulf of Alaska, westward to Japan. And at the same time, you see some cooler water right up along the west coast of the US and Canada. So that's indicative of the cool phase of the Pacific Decadal Oscillation. So we're looking for years that have that in play. And then look at all the warm water across most of the Atlantic Ocean. So the warm phase of the Atlantic multi-decadal oscillation. So what we like to do is look back in the historical record and look for years that have similar ocean temperature profiles. And that can give us some clues as to where the pattern might be going. Let's focus in on ENSO here for just a second. And what you're seeing here are ENSO average sea surface temperature anomalies from forecast centers all across the world. So we see many centers taking a stab at it here. And what you're seeing, the thick red line is the average of all the guidance here. There is a little bit of variability, but just about every model is in that La Nina stage where it has to be minus 0.5 degrees Celsius or lower through the winter season. No model at all is in the El Nino stage. And there's a few that have the cooler end of ENSO neutral. So there's pretty high confidence that La Nina is going to be visiting us, and well, it already is, and it will hold through the winter season. It could be a moderate event. So let's take a look at some analogs, which are average weather conditions from previous years with similar ocean temperature profiles that are expected this year. And let's focus in on ENSO again for just a second. And our top 10 analog years in order, you see they're on the right, but they all feature the same thing. You see kind of a neutralish summer over there on the left, and then through the winter season, every one of them dips into that La Nina threshold. A couple of them are strong. Most of them are in that light to, or weak to moderate stage. So our analogs are all suggestive of La Nina. And focusing on other locations, sea surface temperature analogs from December through February, and the area west of South America is well covered. You see all that blue and purple, all that cooler water, matches the model guidance pretty well. And then you see the warmth from Japan all the way through that area south of the Gulf of Alaska. So we have that covered well. And then the Gulf of Mexico and the Atlantic warmer than normal here. So we've picked years that have similar ocean temperatures and what the ECMWF models I showed earlier suggest. Let's focus on the jet stream for just one moment. And usually where the jet stream goes, the storm track goes and some winds go with it, things of that nature. And where you see the greens and yellows and oranges on the map, that's stronger than normal jet stream winds. So the jet stream is forecast to be above across the northern part of the country during the winter. See a weaker area along the southern part of the country, and then another subtropical jet down below towards the equator that is pretty suppressed. So let's take a look at some analogs based on all of that. And for each of these months coming up here, you'll see temperatures on the left and precipitation on the right, where you see on the left, you see the blues, that's below normal temperatures. Where you see the oranges, that's above normal temperatures. On the right, where you see precipitation, the greens are above normal precip, and the oranges are below normal. So good signal for cold for the western and central part of the country from the analogs, with warmth across the eastern part of the country. Precipitation wet in the east, a little drier in the Pacific Northwest, but a little bit wetter across the desert Southwest in California. For December, winter is here. according to the analogs. They're going to go with below normal temperatures across a lot of the central and eastern part of the country, but the focus is more or less in the upper Midwest and Great Lakes. And the precipitation is pretty much where the cold is for the most part, above normal from the Midwest up through northern New England and southeast Canada. Below normal precipitation across the southeast and along the west coast. For January, looks like a January thaw for a lot of places, near to above normal temperatures across most of the country. Very little below normal in there, so a pretty good extended January thaw from the analogs, and pretty dry too. So it's indicative of a pretty good break in the pattern, which would be nice. For February though, we have different story. We have above normal temperatures, pretty good signal along the east coast, but a good signal for below normal temperatures across the west and the north central part of the country. And if you look, there's a pretty good gradient going across the upper Midwest through about North Texas and New Mexico there. And usually when you see those gradients tighten up, the precipitation shows up. And sure enough, you see that on the right, a lot of precipitation from the Mississippi Valley, most of the plains up to the Great Lakes in the Northeast. So definitely a signal for some wet weather, but not so much across the west and the southeastern coastal areas. Finally, March looks a little bit like last year. Above normal temperatures, central and eastern part of the country. So maybe another early spring preview with the coolness pretty much restricted to the west coast. Precipitation, the Arklatex region, the lower Mississippi Valley is under the gun for some heavier precipitation, but there's a lot of dry conditions around it. So the early end of winter from the analogs, we'll see how that goes. So wrapping it up, the 3-month average, December through February, would be near below normal across north central and northwest, with above normal temperatures across the east coast and near the Gulf of Mexico. Precipitation shows an inland storm track from the basically Oklahoma, central plains up through the Great Lakes and into northern New England, with below normal precipitation basically from most of the east coast, especially the southeast and across the west coast. What does La Nina typically do to snowfall? Well, if you look at all La Ninas, which is on the left, you see the blues, that's above normal snowfall, where you see the browns, that's below normal snowfall. And for most, La Nina typically gives you above normal snow across the Northwest, Northern Rockies, and then the upper Midwest as well. And then, of course, northern New England, northern New York, the Great Lakes, with below normal snowfall further south. But if the La Nina is pretty weak, that tends to shift things south a little bit. So you see a stronger signal for snow across the north central part of the country, going down further south towards maybe even the central plains and getting into Illinois. And then you see it sneaking down into New England a little bit. So a little bit more active. The storm track shifted slightly further south than those weaker years. If you go to the stronger years on the right, though, it's it's a lot more restricted. So you have a heavier signal in the Northwest and Southeast Canada, but you have less of a signal from the mid-Atlantic and then over towards Iowa and the Dakotas. So it takes away some of the snow. So it does make a difference how strong this La Nina is as to how much snow will actually fall. And here are some individual years broken down, top 6 analog years. So 2011, 2012 is our top one. That one didn't have much snow. But if you look at some of these other ones, where all these greens are, that's the above normal snow. And it is hitting the northern part of the country pretty good for most of them. So there is some variability in there, but there is a signal for heavier snow in that area where the precipitation is strong, from the central plains up to the Great Lakes in northern New England. Sure enough here, wrapping it all up, snow and anomaly analogs here. So on the left you have snow, where those greens are, that's above normal snowfall. Where the blues are, you'd see below normal. There aren't very many blues, but the greens are more or less focused where you think they might be, in the northern Rockies, Pacific Northwest, and then that area across Southeast Canada has a pretty strong signal into northern New England. And on the right you have freezing rain anomalies here, where you see the blues, that is less ice, less of a risk for freezing rain, where you see the greens and yellows, that is more ice, or better chances for ice. And interesting that it does focus a little bit on the Arklatex region through the Red River Valley between Oklahoma and Texas. And it has a pretty good signal for no ice, or reduced risk for ice from eastern Great Lakes down through the Appalachians and into portions of New England, but it does keep that ice enhanced across northern New York State through northern New England and portions of southeastern Canada. So that's definitely something to keep an eye on going forward here. So let's shift our focus to subseasonal factors. And the polar vortex obviously takes this front and center on that. And then the strength and location of the polar vortex means a lot. And the impacts are strongest in the cold season. You don't see much of that during the summertime. Tropical thunderstorm clusters, the Madden-Julian oscillation, and the location and strength of those also matter. So they can produce north to south jet stream fluctuations and can result in block patterns or stalled jet streams. And it can give you some extreme warmth or extreme cold for short periods, maybe 1 to 2 week blocks, and then before reverting back to whatever the base pattern is. And snow cover and or soil moisture. So nearby snow cover promotes colder temperatures. Brighter color of the snow, sun comes in and gets reflected back out and doesn't warm the ground as much. So yeah, snow cover makes a difference. If you can keep snow on the ground, you'll be colder overall. Your warm ups won't be as warm, and your cold patterns will be even colder. For soil moisture matters too. So if you have dry soil, you get warmer days and cooler nights. And as more of the sun's energy can go to warming it during the day, and then it can radiate off better at night without having to worry about moisture. If you have wet soil, you get some cooler days and warmer nights. So that's the kind of thing that matters a little bit, especially over a long period of time. So the polar vortex, a strong, stable polar vortex, what you see on the image on the left, what you get is a nice strong jet stream, the polar jet stream that goes across portions of Canada, and it keeps that cold air all nice and bottled up there with a general west to east flow of Pacific origin across the United States and southern Canada. So that's a warmer pattern most of the time when you have that. However, when you get a weaker polar vortex, then it can be broken up into several smaller features and could be a pocket of cold air within each one. So the blocking ridge patterns can help determine where these cold pools will locate, and it could be very extreme, as we saw in February of 2021. Prediction time can be limited to under 2 weeks at times. Sometimes we can see it a little bit longer out, but most of the time, the extreme nature of this cannot be predicted until we get closer to the event. Polar vortex analog, so we'll take a look at some 500 millibar height anomalies here to kind of estimate where if there's any polar vortex risks this winter. And for December, what you like to see is a lot of those greens and yellows and oranges closer to the North Pole. When you see that gives the opportunity for some of the blues to be underneath, and you could get some polar vortex disruptions. Well, for December, you get a little bit of a vortex across central Canada, a little early, but a lot of the blocking would be more or less across the other side of the pole. For January, there's blocking north of Scandinavia. The darker oranges show, but underneath the polar vortex would be more or less into Siberia with lower risk across our side of the pole. And then February, you get best chance of polar vortex more or less across eastern portions of Asia, and then another piece maybe across Europe and then the northwestern part of the country. So what this is telling you, it might not play out exactly this way, but what this tells you is that will be opportunities this winter for the polar vortex to move around a little bit, as long as we have those greens and reds, those high heights close to the pole. And La Nina strength can have an influence on the polar vortex. So we took some 5 stronger La Nina years, December through February. We took some weaker La Nina years, December through February. What you're seeing here is a lot more of those blues closer to the pole, the stronger the La Nina gets. So that reduces the risk of the polar vortex disruptions, and it's kind of generally a milder pattern, keeping most of the cooler air bottled up in the north central, northwestern part of the country. If it's really weak on the La Nina, though, you get to see a couple variations. First thing, you see a little bit more of those red colors closer to the pole, and you get to see those blues get a little bit closer to the Great Lakes and on the composite here. So the weaker the La Nina, the higher risk you have of having polar vortex disruptions, but the signal is not absolute. And you can have polar vortex disruptions with stronger La Niñas. It's just that your risks are somewhat reduced. So those are the analogs. Let's go through the seasonal weather models and see if we can find some patterns there and compare it to the analogs that we just looked at for the next few months. Here's the CFS model here, and all that cold air that is in the central and western part of the country from the analogs, you're not going to see that here. Has a very warm signal rate, all the way for most of the country, the exception of South Georgia. And precipitation looks very dry, so that is very different from the analogs. December, we have, again, widespread warm anomalies, but you start to see some cooler air creeping in across Western Canada. You start to see a little bit more precipitation build up across the northern part of the country, the Great Lakes and in the Pacific Northwest to lead the way. Some drier conditions continue along the Gulf and Southeast coasts. For January, most of Canada is shown to be cold here, but warmth across the southern U.S. Again, some precipitation starting to build up from the Ohio Valley up to the Great Lakes and then the Northwest. So a little bit different so far, but February and March look a lot more similar. So you see a little bit more cold air across the northern part of the country, but the better chances will be across the Northwest and North Central, with warmth across the South and into the Mid-Atlantic. Precipitation looks pretty similar, a lot across the north and back in from the Arctic northward to the Great Lakes. And then March, lots of warmth around, although some coolness wants to linger in the North Central and Northwest. And we're staying with the wet pattern Great Lakes down through the Tennessee, Ohio valleys. Again, drier across the southern reaches of the country. The NMME model, the North American Multi-Model Ensemble, this tends to run a little bit warm, but you can see some trends on here, and that can be helpful. For November, lots of warmth, which is a lot like the CFS. December, widespread warm anomalies, but the precipitation starts to show. Great Lakes and the Pacific Northwest, a little bit more active. And then for January, looks like there's some chances, some cold getting in the Northwest and North Central, keeping the warmth in the South and East. Precipitation increases across the northeastern third of the country and across the Northwest again. And February and March, gradually retreating cold across Western Canada and Alaska, with more widespread warm anomalies slowly building in. February, again, dryness, good dry signal across the southern reaches of the country, but above normal precip from the Ohio, Tennessee valleys to the Great Lakes in northern New England and the Pacific Northwest. So that will be it for me. I'm going to send in the closer. Our Vice President of Extended Forecast Services, Steve Strum, can wrap this all up and tell us what the winter's going to be like as a whole. Take it away, Steve. You're on mute.
Thanks, Nate. Sorry about that, everybody. Thanks, Nate, and thanks, Jeff, for taking us through the climatology, what we've seen last year, and all the various factors for this upcoming winter season. And so now I'll go ahead and actually put all that together and take a look at what our current forecast is showing. So for the month of November, we are looking for a trend towards colder weather across a lot of the central and western U.S., especially the northern half of those regions. We have seen certainly widespread warmth for the last few months, but we should start to see, as we head into November, an increasing amount of cold make its way into the northwestern sort of half of the country, but likely still averaging warmer than normal overall across the far south and the eastern U.S. December at this point looks to have the best chance to see more widespread cold, especially across the middle portion of the country. But we are looking to see that pattern kind of flip back to a warmer regime for January before the cold risks increase once again across the central and the western U.S. One thing you will notice, though, is that for the most part, we don't have any of the months meaningfully colder than normal along the East Coast. So that region looks to have the best chance of averaging warmer than normal for the winter season as a whole, with the colder risks generally focused more across the north central and the northwestern U.S. So if you put it together for December through February, again, those areas up there potentially averaging colder than normal for the winter season as a whole, while the East Coast and the far south generally is forecast to average out warmer than normal for the entire winter season. The map on the right shows the probability. So the darker colors indicate a greater chance for warmer than normal temperatures. It does not indicate how strong those warm anomalies would be, just that you have a higher probability of averaging at least slightly above normal if you are in those orange and red colors, whereas the blue colors again indicate a higher than average chance for temperatures coming in on the colder than normal side. Now looking at the HCD side of that, with everything as it's currently forecast, we are forecasting the winter season both for December to February and November to March for the entire heating season to come in a couple percent warmer than normal again, even though there is some cold there, with the higher population areas on the East Coast likely coming in warmer than normal. That should bias the HDD totals onto the below average side of the ledger. Our cold scenario is about 5% colder than normal on an HDD basis, and our warm scenario is about 5% warmer than normal. So notice that our forecast is closer to that warm scenario. That also indicates there's actually more cold risk than there is warm risk to the forecast at this point going forward. If we look at those risk scenarios, again, we have a 30% chance of the cold scenario panning out and a 20% chance on the warmer scenario. But one thing that'll be key here is that if you remember those monthly forecasts, we do have a lot of that cold focused during the month of December. And so if we're a month from now and there's no sign of cold coming in for December, then obviously the risk for that cold scenario to play out is going to be a lot less since, again, we're looking at cold in December and likely in February, but likely a lower risk in January. And so, the December cold is going to play a big role in that cold scenario potential going forward. So that will be key to watch as we progress here through the next few months. And obviously, if we see a stronger La Nina than expected, that's going to decrease the risk for a weaker polar vortex, and so likely also decreasing the risk for significant cold. So we'll be watching the strengthening of the La Nina here the next couple of months as well. Now looking at some more HCD graphs here, the top just shows the yearly November to March totals. And so you can kind of see that this winter is currently forecast to come in a little bit colder than the last two winters for the entire heating season. Again, we had a very cold February last winter, but the rest of the winter was very warm. And so even though we may not see a repeat of February, at any point in the winter season, because the majority of last winter was so warm, we were still expecting to come in colder than last winter for the entire November to March heating season. That would put us, last year we were the 7th warmest on record in terms of HCD totals. This year is going to be a little bit farther down the towards the colder side of things. Again, there are a lot of years that are very, very similar to this, so we'll see how we actually pan out in terms of the rankings. But overall, looking to come in a little bit colder than last winter. And again, the monthly breakdown on the bottom left showing the higher potential for cold there in December. That's the only month we're actually forecasting to come in colder than average on an HCD basis. So again, that month will be key for the entire winter season in terms of those temperature anomaly for patterns and for the HCD total comparisons to normal for the entire winter season. If we go ahead and look at our precipitation totals here, we are forecasting, again, the best potential for above average precipitation to be really focused across the Midwest Great Lakes region of the country, with below average precip likely across the Southwest and the Southeast. And the Northwest also likely coming in wetter than average overall. Obviously, if we do see more of that cold come in, those wet conditions across the areas of the Midwest and Great Lakes will fall in the form of snow in many cases, and that will also increase the risk for more snow than normal in those areas. So for the entire winter season as a whole, again, that corridor there from the central Mississippi Valley up into the Great Lakes, likely having the best chance to see significant anomalies in precipitation for the winter season, but likely not a lot of drought relief for California and the Southwest as we go forward here in time during the course of the next several months. Again, with the potential for more cold across the north central US, those wetter conditions there across the Great Lakes should translate into above average snowfall for those areas. So Chicago, Minneapolis, Detroit, and then eastward across towards New England, likely being snowier than average. Across the South, though, big caveat with those potentials for slightly less snow than average. Snowfall across the South is, the normals are very low, and generally speaking, you're above average in snowfall if you get a snowstorm. And so there's not nearly as much correlation across the far south between, ENSO and snowfall for many areas, just because 1/6 snowfall and suddenly a lot of those areas are above average. So again, slightly better chance for less snow across the south than what we saw last year, and slightly less snow than average expected. But again, if they do see a single storm, many of those areas will still end up averaging snowier than average. If we look at the drought conditions currently, still widespread across the western U.S., we are again looking to see the Northwest coming wetter than average, which should improve drought conditions there. But with the Southwest staying, basically dry throughout the winter season relative to normal, no improvement expected for Arizona, California, those areas down there, and also western areas of Texas up towards western areas of Kansas, potentially coming in drier than average as well, and seeing drought conditions expand eastward across those areas. The main question will just be how far west that wetter area gets across the central Mississippi Valley region, and whether or not we do get some of those higher rainfall totals to push westward, into more of the plains. But overall, certainly the southwestern quadrant of the country likely to see drought conditions at least continue, if not get a little bit worse. Now, looking globally for the winter season as a whole, we are also forecasting the potential for portions of Asia to come in colder than normal this winter season, especially during January and February. Less risk during December in that area there. Europe is currently forecast to come in warmer than normal by a little bit for the winter season as a whole. However, we do expect pretty much a lot of Europe to come in colder than average during the second half of the winter season, especially during the month of February. And so while it is forecast to come in warmer than normal for the entire winter season as a whole, the potential is there that we could see at least one of the months come in quite cold across the entire continent, especially during the second half of the winter season. So not looking to see a winter that's going to produce mild weather throughout the entire winter by any means at all. Now, if we kind of summarize things here, again, the Southwest, warm, dry for the most part for the winter season. The central U.S., going to be very stormy. Also the potential for northern areas to come in quite cold. Though we likely will still see cold shots get into the southeastern quarter of the country as well at times during the winter season, but the warm days will likely outnumber the cold days in those areas. But when the cold days do occur, it's very common during a La Nina to see those cold periods across the southeast be quite extreme. And so while there won't be as many of those down there relative to the north central areas of the country, the potential exists that we could see a significant cold event at some point across the southeastern quadrant of the country. Again, the Northwest likely being quite wet this winter season. In the Northeast, best chance for it to come in colder than average will be December, with the tail end of the winter more likely to come in warmer than average as it looks right now. If we progress on here and look at some renewables here, if we look at our wind forecast, we are looking to see the plains and the Rockies having the best chance for above average wind speeds this winter season, and both coasts likely coming in with less wind than average. The East Coast is forecast to see fewer nor'easters than typical this winter season, with the storm track being farther west towards the Ohio Valley. And so as a result, there should be less wind overall along the East Coast this winter season. In terms of solar, again, all that storminess across the Midwest and Great Lakes will keep more clouds than average in place for those areas. And likewise, the dry conditions across the Southwest will also be accompanied by more sun than average. So generally speaking, above average solar output likely across the Southwest and also portions of the Southeast this winter season. And so again, just to summarize here, some key messages. Again, the analogs favor potentially for a lot of volatility this winter, some potential for some significant cold at times across, especially the central and northwestern portions of the country, but also a better chance for above normal warmth across the South and the East Coast. So again, those areas have a higher risk for warmth this winter season overall. And again, the north central, northwestern areas have the best chance to see the most frequent cold outbreaks. And the polar vortex will be key to that. And the potential exists this winter season to have a weaker than average polar vortex, and thus the potential to have some, significant cold intrusions at times this winter season. And so we'll be watching to see how that plays out going forward. It's hard to predict the timing of that, far in advance, but we will be watching for that to happen this winter season. And again, the overall storm track will generally favor the northern tier of the country to have the higher chances for above average snowfall, and with the core that precipitation anomaly focused across the Great Lakes region. And so those areas in particular could be seeing a snowy winter season. And one thing to keep in mind, La Nina winters do often produce a lot of extremes, both on the cold and the warm side. And so even though the southeastern portions of the country are forecast to average warmer than normal this winter season, it's quite common for those areas to also see extreme cold waves, even during the very mild winter seasons that can accompany La Nina in that part of the country. So while the warmth may dominate in terms of number of days, the days that are cold could potentially still be quite extreme. There just won't be as many of those cold events relative to average.
All right, Steve, thank you very much. Just want to double check here that everybody can hear me okay. Am I coming in clear, Steve?
You're good, Dale.
All right, sounds good. Well, thanks, DTN team, for that review of the past winter, as well as the forecast coming here for 2021-2022. So now I'll talk a little bit about the aviational impacts for how the weather forecast going forward. And all right, well, make sure I can advance on the next slide. Let's see here.
You should be able to click on the left-hand side there below the slide number to advance it. I can advance them if you need me to.
Yeah, why don't you go ahead there, Steve? I guess I'm having trouble trying to do that, but go ahead and advance to the next slide. That'd be great. Oh, I think I got it now.
Okay.
All right, thanks. Sorry about that. All right, so just to go over really quickly, just to kind of review some key messages that we learned here from the forecast of the upcoming winter and how that can impact operations in the aviation industry, and what DTN can provide to help mitigate some of that risk coming up here in the winter. So some key messages that we heard is that there's going to be a stronger than average jet stream over the northern tier of the U.S. And so from that, subsequently, we're looking for more of a turbulent threat from the Rockies eastward to the Ohio Valley and the Great Lakes. We also heard that there's going to be more of a stormy pattern over the northern tier of the country. So that will also increase risk for storms and lower visibilities, and more precipitation. And also the increase for thunderstorms will be heightened as well from the Arkansas, Louisiana, Texas region up and through the Tennessee and Ohio valleys. So again, we saw earlier that the jet streams are going to be strongest across the northern tier of the United States and weaker across the southern tier. So from a turbulence perspective, what does that mean, right? Which in turn looks for that you're going to have, impacts for the amount of fuel that you're going to burn. You really want to try to optimize your routing and to reduce that fuel costs and usage, as well just in general to reduce your carbon footprint. So one of the means you can do that through DTN solutions is a web-hosted application that we have that's called Aviation Sentry, something that you can access via your computer, your tablet, or smartphone. Provides a full suite of aviation graphics, flight hazard forecast information, lightning information, alerting, and it's available in multiple languages. So something that can be used, across the world to support aviation operations. So from a jet stream perspective, we do have all the altitudes, low, mid, higher altitude range for forecasts for the wind speeds. It's with the wind barbs and the wind speeds associated with that. Gives you the direction of which way the jet stream will be moving, and it's colored contoured as well for ease of just to pick out very quickly where the strongest jet streams will be located in the forecast period. And that forecast period goes out for the next 24 hours and updates every 6 hours with 6-hour hourly intervals. So from the strong jet stream, subsequently you're looking at the probability of stronger turbulent events. And again, we're looking at from that perspective, more mountain wave activity across the Rockies, and then clear air turbulence associated with the strong jet stream eastward across into the Ohio valleys. obviously the impacts that has from an operational perspective with the severe turbulent events means that there could be downtime for your aircraft, which due to inspections or maintenance from if you do have come across a significant turbulent event. Of course, you want to make sure that your safety there for your passengers and for the crew to try to avoid any turbulent areas that are being forecasted during these strong jet stream events. And lastly, obviously nobody wants bad press exposure. You don't want to be in the news for having your routes, your planes diverted, or any injuries being reported as well. So means to do that, to try to mitigate the probability of having a severe turbulent events, is by leveraging DTN's EDR turbulence forecast model. And this is a proprietary model that's in a combination of using the atmospheric models, the same models that help tell you when it's going to rain or snow or what the temperature is going to be, but in conjunction with DTN proprietary algorithms. And this model, this EDR, which stands for eddy dissipation rate, is an ICAO standard, and it's on a scale for large to medium to small aircraft. So there's specific values forecast based on the type of aircraft that you're flying, and that's how you can find out where the strongest turbulence is going to be based on the type of aircraft that you're flying and what impacts that's going to make for the turbulent events, and how you can try to avoid that. The forecast here is updated every hour, and it's forecast out through the next 18 hours. So moving onward, we heard a little bit about how thunderstorms are going to be impacting the central part of the United States. And, from that, there's other contingency plans you can make from an operational perspective, if you want to look at it more from the ground means. So, planning about for your team, for avoiding or when to expect, I should say, significant weather is going to impact thunderstorms, for example, and how that may affect the unloading or loading of baggage, for example, and just to protect employees and passengers and assets as well when those severe thunderstorms are occurring. There's many graphics available through Aviation Century and forecasts available to take a look at and plan ahead, to strategize ahead days in advance of where the significant storms are going to be impacting over the next 1, 2, or 3 days. So you can look at these graphics to kind of plan ahead. Then as those storms are in your area or approaching your airport, you can look at the DTN real-time radar through Aviation Century, or use the storm path tracking tools that are available to let you know when the storm is exactly going to impact your airport, at what time, and the intensity of that storm, whether there's any hail involved or a strong thunderstorm or even any tornadic activity. And within Aviation Century, we've got our alert engine. So you can set up many parameters, dozens of different weather parameters for lightning, for possible tornadic activity, for hail activity. These messages are then sent to your laptop or computer. They also can be sent by a text message or email message, and you can determine who and when you want those alerts to be received for the heads up of when these storms now are approaching your airport. And lastly, one of the things we talked about was, we had a forecast here is with the storms approaching the northern tier of the United States and into Canada. That's going to impact the visibility of the airports, and obviously that can determine possible delays for your aircraft at a given airport, and that can also add to additional fuel loads that have to be put on the aircraft when the lower visibilities or the storm is going to impact a given area where your aircraft is flying to. So again, there's a full suite of aviation graphics in Aviation Century, and one of these is a geospatial forecasts out for the next 24 hours to show you areas of low IFR or IFR conditions forecast during a given hour out for the next 24 hours. But for further insight, you can get some value-added forecasts through the DTN Aviation Meteorology team. And so you're able to consult with them at any time during 24 hours and 7 days a week to get forecast consulting. And one of the most common forecasts that's used by the aviation industry today is what's called a RAMTAF. It's a terminal forecast for an airport or for any location, and this can be done for any location, literally around the world. And it's a forecast for the next 18 out to 36 hours for ceilings and visibility, wind speeds and direction, and how that's going to impact a given airport. So with that, that summarizes how DTN's Aviation Sentry can help mitigate operational risk for your business.
I think, Nate, have you been monitoring questions? Do we have anything that has come in?
And we have had a couple come in. And here's the first question. Since I was a polar vortex guy, I guess I'll answer it. Would weak polar vortexes be considered more bullish demand as the cold makes its way into the southern demand centers? Well, the short answer to that is yes, they would. The thing about it, though, is it's not always an equal impact. So polar vortex can be disrupted or split or sent southward, but it doesn't necessarily mean it's going to head towards an area of high energy demand. You could easily have some of the coldest air go to the other side of the pole, go into middle of nowhere in Siberia or out into, could go into Western Canada and Alaska, which would not be great for those guys, but those aren't the high demand areas. So yes, if the cooler air were to get down in there, that would definitely increase the demand, but a polar vortex disruption does not have a one-to-one impact of the colder air getting into those southern demand centers. I think another one came in. What role do you think the sunspot cycle is going to play in the winter's outcome? I think you're well versed on that part, Steve. Can you help us out?
Yeah, I can go ahead and answer that. So there's a couple of things that happen as the solar cycle increases. We see more sunspots. The UV output from the sun, ultraviolet output, gets higher more than anything else, and so often we'll see a situation where we have a little bit more energy coming in at that end of the spectrum into the Earth's atmosphere, and so the ozone layer absorbs that UV light, and because the equatorial areas get more of that sunlight coming in, the atmosphere and the stratosphere areas heats up more relative to the areas towards the poles. So typically, as the sun gets more active, we tend to see a bigger temperature gradient in the stratosphere between the pole and the equator, and that tends to help induce a stronger polar vortex during the winter season. However, we just came out of solar minimum and sunspots ramping up, and so typically a negative Arctic oscillation where you have the weaker polar vortex and all that is more common when we have low solar activity. We also tend to see that happen when the sunspot activity first starts dropping down. So it's not just the, when we see it, first kind of go over the top of the hill essentially and start decreasing, we'll oftentimes see that winter have, a negative Arctic oscillation kind of predominate. So sunspot activity is just starting to increase after the solar minimum. So it's kind of hard to say what impact we'll have this particular winter. But as we do see it increase in the next couple of years, that generally speaking lowers the risk of a negative AO during the winter, but obviously we have had cold winters with a positive AO, and it doesn't, that's not the whole ball game when it comes to how the temperature pattern plays out. But that is the biggest impact we typically see is a stronger polar vortex and a positive Arctic oscillation when solar activity is ramping up strongly, which will be the case probably the next 2 winters, but not as much this winter since we just came out of the solar minimum.
Awesome. Thank you very much. That's good information, Steve. Another one came in here, more or less in the same category as the polar vortex. It did seem that we're not predicting a whole lot of high latitude blocking, which would cause the U.S. to be cooler. So I'll continue with that one. Looking at the polar vortex analogs that we looked at before, it did show a pretty good signature of having some blocking show up north of Scandinavia. That was the best high latitude blocking example that was shown on there. So the impacts of that would be a little bit some cool risks across Europe and especially across downstream areas of Siberia. So we have that's why we're predicting some of the colder temperatures later in the winter in that part of the world. But that doesn't mean that we can't have short spurts of high latitude blocking that could occur in areas that have more impact on the U.S., like say around Alaska or near Greenland. It's just that we don't expect it to be a persistent feature this year. We expect to be the blocking on this side of the pole to be somewhat less pervasive. But as we saw in February, this past year, the ingredients can come together for a short period to produce some sharp cold spikes, and high latitude blocking showed up at that point, and it could easily do that again for a short stretch this winter. Last winter, it impacted the central part of the country, but it could easily get into the northeast if we have the right configuration set up. Again, expecting it to be brief, we have more warmth than cold predicted in the northeast, especially across the eastern part of the country. And let's see. We had one more come in. Are we fully switched over to the 1991 to 2020 30-year normals in our forecasts?
I'll go ahead and answer that. Yeah, all of our forecast graphics, our actual forecast anomaly graphics, those are all based on the 91 to 2020 normals. So those have all been switched over. So that is an important note. If we were showing these graphics relative, so the new normals are essentially warmer during the winter season than the old normals were. And so if we were showing the forecast relative to the old 81 to 2010 normals, because that baseline was a little bit lower, the forecast would generally look a little bit warmer than what it currently does. But since the new normal baseline is a little bit higher now, that does tend to shift the forecast a little bit cooler. Now, in terms of some of the model graphics, not all the model graphics are switched over to the new normals, especially for pulling those from like NOAA or different websites. It's kind of a mix match right now of normals on various sources for for model data. But our own forecast graphics are all based on the 91 to 2020 normals, as are those degree day comparisons that we showed. The 30-year normals for the degree days are based on that 91 to 2020 period.
Very much, Steve. One last one popped in here. It seems as if we're expecting the MJO, the Marian-Julian oscillation, to be mostly in the warm phases, 4, 5, and 6. Is this due to the sea surface temperature configuration? I can definitely take that one. The sea surface temperature configuration does play into it. Some of the warmest water temperatures in the world, especially during the winter season, are located across the western Pacific Ocean and portions of the Indian Ocean in the tropics. So this particular year, especially with the La Nina predicted, you tend to have the warmer water in the eastern Indian Ocean and into that maritime continent region near Indonesia and then out into the western Pacific. So a lot of times all the tropical convection that can cause all the ups and downs in the jet stream pattern or lack thereof should be in that particular region. 4, 5, and 6 will be fairly common. However, there's going to be some short stretches where it's able to go across and through the Pacific Ocean and then through the Americas and then back into the Indian Ocean from there. When you get those short stretches, that could be one of the things that can trigger some cooler responses across portions of the central and eastern part of the country. And again, this would be short-lived. So this kind of plays into that. Sometimes the MJO can be the cause of the polar vortex disruptions. And that could easily occur this year. So phases 7, 8, 1, and 2 cannot be ruled out either. Let's see, are there any additional questions that have come up in either one? I believe we have reached the end of that. Andrea or Steve, I think we can close this up.
Yeah, just want to thank everyone again for joining us today for this Winter Outlook webinar. Again, this event was recorded. We will be sending out information on how you can access that recording once we have it available from WebEx. So probably it'll be sometime next week, but we will be sending that out to everyone who registered for the webinar. But anyway, thanks again for joining today and have a great day. Bye.